Have you ever stopped to think about the ground beneath your feet? What if I told you that the Earth itself is a living machine, constantly shifting, cracking, and evolving? In the next few minutes, we're diving into the heart of that machine. Get ready for an eye-opening journey that will take you from the sidewalks of your neighborhood to the fiery core of the Earth. Stick around, because what you're about to learn might just change the way you see the world forever. Planet Earth, our only home, is more than just rock, soil, and oceans. It's an engineering marvel, driven by unstoppable forces hidden beneath its crust. While most of us are busy with our day-to-day lives in cities and suburbs, we have no idea what's actually going on beneath the surface. Today we'll peel back the layers of Earth like never before. Using radar, sonar, and satellite imagery, scientists have created a virtual planet Earth, and it's nothing short of breathtaking. Let's start with what we can see. On the surface, our planet is alive with volcanic eruptions and earthquakes, signs of the immense energy moving within. These aren't random. They're symptoms of a deeper system. Just 100 feet below city sidewalks, we find a maze of utility pipes, subways, and tunnels. But even that's just scratching the surface. Beyond 300 feet, human infrastructure fades. And no one has ever gone deeper than 2.5 miles into Earth's crust. Why? Because the Earth's core lies almost 4,000 miles below us. And it's no ordinary place. Imagine a giant ball of metal, almost the size of our moon, burning as hot as the sun's surface. That's the inner core, the Earth's engine. It radiates heat that rises and reshapes the planet's surface. This process started 4.6 billion years ago, when Earth was just a ball of molten lava. Over millions of years, the lava cooled, forming a solid crust. But the story didn't end there. New types of lava erupted, forming floating plates that became the continents. And from deep within, two key elements, hydrogen and oxygen, combined to create water. Thus, the first oceans were born. The Earth machine had built its foundation. Now let's break down the crust. It might feel sturdy under our feet, but it's thin, like the skin of an apple, just 3 to 45 miles thick. It's broken into 14 massive tectonic plates that drift up to 6 inches a year. And when those plates grind or crash into each other, that's when we get earthquakes and tsunamis. One incredible story begins with a tiny crack in Florida's ground. It didn't look like much, but water began to seep through. Over time, that water carved out a colossal underground river system, the Floridan Aquifer. Covering 100,000 square miles and supplying over 3 billion gallons of fresh water a day, it's a hidden lifeline for Florida and neighboring states. Biologist Tom Morris leads a team of cave divers exploring this network. Their mission? To map the labyrinth and protect it from pollution caused by overdevelopment. They squeeze through tight rock holes, dive 80 feet down, and navigate fast-flowing subterranean rivers. It's claustrophobic, risky, and vital. Why? Because that's where our drinking water comes from. At the surface, a transponder system tracks the divers' every move, pinpointing their location through rock and water. These maps are essential for environmental safety. With each dive, more of this underground world is revealed. But while Florida's aquifer is hidden, other areas deal with disasters in plain sight. When two tectonic plates clash, the result is catastrophic. Just ask New Zealand. In 2011, a powerful earthquake collapsed the Christchurch Cathedral spire, killing 182 people. And just a month later, Japan faced a magnitude 9 quake, followed by a tsunami that claimed as many as 25,000 lives. The Pacific Rim, stretching from Chile to Alaska to Asia, is a hot zone for tectonic activity. In just the past 50 years, dozens of massive quakes have devastated countries and taken thousands of lives. Even in the United States, we're not safe. At the University of California, Berkeley sits Memorial Stadium, home to the Golden Bears. But this historic arena rests directly on a fault line, literally from one goalpost to the other. Geologist Roland Bergman has been monitoring this line for years. According to his findings, the fault is slipping at just 4 millimeters a year, half of what it should be. This means pressure is building underground. And when that pressure finally releases, the results could be disastrous. Experts predict a massive earthquake is due. So what's being done? The Bears are splitting the stadium in two, placing each half on separate floating concrete blocks. This way, if the earth shakes, the two sides can move independently, reducing damage and saving lives. It's a $320 million project designed to protect fans when, not if, the next quake strikes. The last major quake on that fault was 140 years ago. Today, millions more people live in the Bay Area. When the big one comes, it'll be more destructive than anything we've ever seen. But thanks to science, preparation, and innovation, Places like Memorial Stadium will be among the safest spots to ride it out. What's the takeaway here? The Earth is alive. It breathes, shifts, and changes every second. We may not feel it, but below our feet is a machine. One with the power to destroy but also the wisdom to sustain life. From the depths of aquifers to the roar of tectonic plates, understanding this machine is key to surviving and thriving on our unique planet. If you found this journey into the Earth machine fascinating, don't forget to like, share, and subscribe to our channel. We've only scratched the surface. There's so much more to discover. Hit the bell icon so you never miss our next deep dive. Thanks for watching, and remember, every step you take is powered by the planet beneath you. Roland Bergman takes to the air to survey the fault line. The fault that is pulling apart the Golden Bear Stadium is called the Hayward Fault. It's part of one of the most famous geological features in the world, the San Andreas Fault. This fault system runs 800 miles from the south to the northern coast of California. Earlier quakes along the San Andreas Fault tore the land apart. And now, flying directly above it, the visual clues are undeniable. The lake beneath them, Crystal Springs Reservoir and San Andreas Lake, stretches like a scar across the land. The reason it's so long, narrow, and perfectly straight is simple. It formed directly along the fault line. As the fault grinds and scrapes, it erodes a path through the rock, carving valleys that fill with water over time. Back in the hangar, the virtual Earth lights up with 50 years of earthquake data. It clearly shows that the world's most significant fault lines lie between tectonic plates. It only takes a shift of an inch or two to cause a quake. But over millions of years, those tiny slips add up to massive displacements. In fact, rocks now found in Northern California originally formed hundreds of miles away in the south. This movement, though slow and often imperceptible, has the power to reshape entire continents. In another 9 million years, Los Angeles and San Francisco will be side by side. No road trip required. Tectonic plates move constantly. Sometimes they slide or creep quietly past each other. Other times they crash together in violent collisions, buckling the Earth's surface to form vast mountain ranges. 50 million years ago, India's tectonic plate slammed into Asia. The force of that impact created the towering Himalayas. Today that same pressure continues to push upward, and Mount Everest, the highest peak on Earth, grows by about 0.2 inches every year. Inside the virtual Earth, we see a planet divided into 14 colossal tectonic plates, each in relentless motion. They slide, collide, and shift vertically, creating not just mountains and valleys but entirely new landscapes. One of the most dramatic examples of vertical change can be found in Alaska. Welcome to Glacier Bay National Park, home of sweeping ice fields and endless skies. The land here is rising, literally. What was ocean floor just decades ago is now dry land. A ranger, Sierra Willoughby, points out a curious sight. A cabin that once overlooked open water now sits hundreds of feet inland. When the last ice age ended and glaciers melted, the massive weight lifted off the crust. The land began to rebound. That process continues today, so while the cabin may have lost its view, golfers at nearby Mount Fairweather are gaining new fairways every year. The Earth's crust spans nearly 200 million square miles. It appears diverse: hills, plains, mountains, oceans, but it's built from just 3 basic types of rock. First, there's igneous rock, born from molten magma. In North Carolina, the world's largest open-face granite quarry extracts 83,000 tons of igneous rock every year. Then there's sedimentary rock like limestone, formed from compressed seabeds. Lastly, metamorphic rock, like marble, is created by extreme heat and pressure that transforms other rocks. These 3 rock types are the fundamental building blocks of every landform on Earth. But where does all this molten rock come from? To find out, we dig deeper, past the crust into the mantle. The Earth's mantle is an 1,800-mile deep furnace reaching temperatures of up to 2,200 degrees Celsius. It's here that magma forms. Hot, buoyant, and under immense pressure, this molten rock rises and collects in chambers within the crust. Combined with volatile gases, the pressure builds. Eventually, the only way out is up. Explosive eruptions burst through the surface as volcanoes. Most volcanoes operate this way, fueled by magma chambers just 10 miles beneath our feet. But some volcanoes are exceptional. Mount Nyiragongo in the Democratic Republic of the Congo is one of the most active and mysterious volcanoes on the planet. In 2002, it erupted violently, killing 147 people. It rises 2 miles above the surrounding land and holds one of the world's largest permanent lava lakes. This lake, over 750 feet wide, boils at nearly 800 degrees Celsius. What makes Nyiragongo unique is the depth of its magma source. Scientists believe the lava might be fed by a vertical column reaching deep into the Earth's mantle, far deeper than most volcanoes draw from. Dario Tedesco, one of the world's leading experts on Nyiragongo, describes it as unlike any other. There are so many secrets in this volcano that you don't see anywhere else, he says. To uncover those secrets, Dario leads a team into the crater. Their mission: collect a lava sample. It's an extreme expedition. First, they descend into the crater, navigating unstable rock and searing temperatures. The slope is so steep it could swallow a skyscraper. The Empire State Building could fit within the crater. As they reach a series of ledges, they must rappel down sheer rock walls, one drop exceeding 600 feet. The ground beneath them is fractured, venting sulfurous gases. The deeper they go, the more dangerous it becomes. Eventually, they reach the second ledge. It's time to camp for the night. Darkness falls fast, and the glow from the lava lake lights the crater in an eerie red hue. They rest within one of the most dangerous environments on Earth, knowing the volcano could change without warning. The Earth is a machine, complex, powerful, and always moving. From the grinding fault lines in California to the growing peaks of the Himalayas, from rebounding coastlines in Alaska to the fiery depths of Nyiragongo, it's a planet constantly reshaping itself. And while we live just on its surface, understanding the forces beneath can help us prepare for the challenges above. If you found this journey through the Earth's layers as fascinating as we did, be sure to hit that like button and subscribe to the channel. Share this video with someone who loves science, nature, or just a good story about the world we live in. Let us know in the comments which part of the Earth machine amazes you the most, and what you want us to explore next. Stay curious, stay safe, and we'll see you in the next deep dive into our extraordinary planet. While the team sleeps beneath the shadow of Mount Nyiragongo, the Earth remains anything but still. Deep in the crater, the lake of molten lava continues its relentless churning. This is not a place of silence or peace, it's a cauldron of searing fury. The lava bubbles and surges, occasionally sloshing over the crater's rim like an angry tide, spilling glowing rivers down the mountainside. Nyiragongo is not only one of the world's most spectacular volcanoes, it is one of the most dangerous. This is because Nyiragongo's lava moves fast. Not just fast, it's the fastest lava on Earth. In full eruption, it can race downslope at more than 60 miles per hour. That's faster than a sprinting human. It's faster than traffic on some highways. And once the lava starts flowing, there's no running from it. Morning arrives. The air is thin, hot, and tainted with sulfur. The lava lake has calmed, slightly, its surface now glowing rather than frothing. Dario Tedesco watches closely as one of his colleagues approaches the lake's edge to collect a sample. The scientist wears a high-heat protective suit, designed to withstand intense thermal radiation. But even with all this preparation, nothing can guard him from direct contact with lava. It's still a deadly mission. Dario grows nervous. The lava is edging closer to the rim. "This is crazy," he mutters, watching his colleague push forward. "Too close, it's just on the rim." His voice rises in tension. "Come back. It's too long. Come back." The scientist hesitates, gets what he needs, and retreats just in time. Moments later, lava bubbles over the rim again. Once the lava cools and solidifies at the base of the crater, a sample is retrieved and packaged. That hardened lava will soon make its way across the globe, to a lab in upstate New York. At the University of Rochester, geochemist Darrah prepares to analyze it. The rock is crushed under pressure, then superheated in a furnace, allowing trapped gases and volatile elements to escape. These tiny chemical signatures reveal secrets hidden deep within the Earth. The results? Stunning. Tom's analysis shows the lava isn't just from the crust or upper mantle. It appears to originate from the very base of the mantle, over 1,800 miles beneath the surface. This means Nyiragongo might be tapping into one of Earth's deepest magma sources, a place almost no volcano on the planet reaches. Back on the virtual Earth model, a massive upwelling of heat, known as a mantle plume, is visualized rising beneath Africa's Rift Valley. These plumes can transform continents, causing earthquakes, lifting land, and birthing chains of volcanoes. It's possible that Nyiragongo is only the beginning. In the future, the Rift Valley could tear itself apart, and a new ocean might form, splitting Africa in two. But not all samples from the Earth's depths come from volcanoes. Some of them are sold in jewelry stores. Diamonds. Glittering, polished, prized across the world. Yet their origin lies in the most extreme places on Earth. Forged under immense pressure and blistering temperatures, over 1000 degrees Celsius. Deep inside the mantle, diamonds are born. During volcanic eruptions, fast-moving magma can carry them toward the surface. Not all make the journey. Some get stuck, others are destroyed. Only a lucky few survive, eventually arriving in human hands. Virtual Earth reveals just how rare this journey is. Diamonds come from very specific types of volcanic activity, and that's why they're found in just a few regions on Earth. South Africa, Russia, Canada. Beautiful stones, created in brutal conditions. But diamonds aren't the only thing humans can harvest from the mantle's energy. Travel north, far north, to the edge of the Arctic Circle. Welcome to Iceland. Here, the crust of the Earth is unusually thin. In some places just 6 miles thick, close enough for Earth's heat to make itself known. As cold water seeps into the ground, it heats quickly, transforming into high-pressure steam. Geothermal plants across Iceland capture this steam, converting it into electricity. This natural system powers almost the entire nation. Homes are heated. Greenhouses grow food year-round. Even the streets of Reykjavik are kept snow-free in winter by warm water pipes running beneath the pavement. And here, in a remote coastal town, Icelanders swim in a geothermally heated bay. The seawater just beyond is near freezing, barely 4 degrees Celsius. But inside the bay, it's a comfortable 29 degrees Celsius. Warmed entirely by the Earth's internal heat. Back at the hangar, the virtual Earth is revealing its deepest layers. We journey beyond the crust, deeper than the mantle. We arrive at the outer core, a colossal sea of molten metal spinning around the very heart of the planet. This outer core, made mostly of iron and nickel, is unimaginably hot, reaching up to 6,000 degrees Celsius. But more than just heat, it generates something vital. Something invisible, yet powerful. Earth's magnetic field. This field extends thousands of miles into space, forming a protective bubble around our planet. It shields us from the sun's constant barrage of high-energy particles. Without it, life on Earth would not exist. Sometimes we can see this shield in action. The northern lights. In the skies above the Arctic, solar particles interact with the magnetic field in Earth's atmosphere, producing dazzling curtains of light. Pink, green, purple. They shimmer and dance across the night sky, a visible expression of the invisible forces at work. This field, powered by the spinning molten metal in the core, also provides direction. North, south, east, and west. It's the basis of compass navigation. But its influence reaches even further than we imagined. In the cold waters of the North Atlantic, a small creature embarks on a massive journey. A young loggerhead sea turtle. Born on the beaches of North Carolina, she swims thousands of miles across the ocean, guided not by sight or scent, but by Earth's magnetic field. At the University of North Carolina, marine biologist Ken Lohman studies this phenomenon. He outfits a turtle with a lightweight harness connected to a tank surrounded by magnetic coils. By controlling the magnetic field in the tank, he can trick the turtle into thinking it's somewhere else on Earth. The results are astonishing. When the field is changed, the turtle changes direction. It turns out that turtles have tiny crystals of magnetite in their brains, the same mineral found in compass needles. These crystals allow them to detect and navigate using the planet's magnetic field. It's like they have a natural GPS in their heads. Even more remarkable, they don't just know direction, they know location. These turtles can use variations in magnetic intensity and angle to determine their precise position in the vast ocean. Years later, the same turtle that swam to Europe will return, back to the exact beach where she was born, guided by the Earth itself. And all of this, every magnetic field, every turtle's journey, every northern light, is powered from nearly 2,000 miles beneath our feet. Even deeper than the outer core lies the inner core, the very center of the Earth. A sphere of solid metal, compressed under such immense pressure that it remains solid despite being as hot as the surface of the sun, over 6,000 degrees Celsius. This is the engine of the Earth machine. From this blazing, spinning core, heat rises. Vast thermal plumes travel upward through the mantle to the crust. There, they drive the motion of tectonic plates, shaping continents, creating oceans, forming mountains. These plumes eventually cool, sink, and return to the core, completing the cycle. A cycle that has repeated for billions of years. Many scientists believe that, in time, this continuous motion will once again force all Earth's landmasses together. One day there may be no separate Americas, Africas, or Europes, but a single supercontinent. An unimaginable landscape. It will take 250 million years. But if we could see it, we'd witness a planet completely transformed, driven by the same forces that are shaping our world today. And it all begins more than 3,000 miles beneath our feet. A ball of solid metal. Hotter than fire. Spinning. Alive. This is Earth. The ultimate machine. The journey of a drop of lava, the shimmer of the aurora, the flight of